answer. So start. So I want you to write the question and I want you to think what is the answer and give me the answer. Start. Try to give me the answer. Answer for both are same. So think about it. First one is the EM wave emitted by the sun and responsible for heating the Earth's surface or Earth's atmosphere is due to the greenhouse effect. Now, which gas is responsible for greenhouse effect? Answer will be infrared radiation. And the same answer, Earth's atmosphere is richest in infrared. Both answers are same. That is why I want you to write this MCQ and write the answer as important point. And the second one also write the question and write the answer as important point. Make a note. First one also answer is infrared radiation. And the second one also answer is infrared radiation. Make a note quick. Make a note of both the answers. First one answer is infrared radiation. Second one also answer is infrared radiation. Make a note of both. Okay, so we'll go to the next topic. See, these kind of MCQs are very important because it's easy marks. So you should know for the first one also answer is infrared, and for the second one also answer is infrared. Okay. Now, next topic, write down side heading, types of signal. And there are two types of signal, analog signal and digital signal. Write down side heading, types of signal. Write down next side heading, types of signal. Next side heading, types of signal. In that first one is analog signal and the second one is digital signal. First one is analog signal and the second one is digital signal. Please keep your camera on, otherwise I'll have to put you out. Types of signal is analog signal and digital signal. Written this topic. After that, make two columns. One side you write analog signal, other side you write digital signal. One side you write analog, other side you write digital. One side you write analog, other side you write digital. See here. First, let me tell you the topic, then you can make the notes. See this. Everyone, look at the screen. See here. Analog signal looks something like this, and digital signal looks something like this. Now, if you see, this kind of signals you might have seen, this is a sine wave. And this kind of signals also you might have seen. You might have done bar graph in your 10th standard or 9th standard where you might have seen such signals. Okay. Now, this kind of signal is called analog signal, and this kind of signal is called as digital signal. And the other name for analog signal is continuous signal because it has continuous values. And the other name for digital signal is discrete signal. Discrete means discontinuous because the signal can take only two values, either 0 or maximum. Okay. So the signal, this is also called as binary signal. You know what is the meaning of binary? Binary means two. Two means it can have only two values. Either it can have minimum or it can have maximum. But if you look at this graph, it has all the values between 0 to +5 and 0 to -5. That is why this analog signal is called as continuous signal because it has continuous values. There is no break in the signal. And discrete signal is also called as digital signal. Okay, that is our discrete signal. And the other name for discrete signal is digital signal, and it is also called as binary signal. And it has only two values, that is either it has 0 and maximum. Therefore, if a signal has continuous values, it is called analog signal. And if a signal can take only two values, it is called as digital signal or discrete signal. Therefore, you have written the side heading analog signal, digital signal. Now make two columns. On one side, write down analog, and on the other side, write down digital signal. Have you done that? Have you made two columns? On one side, have you written analog, other side digital. Now, under analog signal, first draw the diagram. Under analog signal, first draw the diagram. That's it. Don't write anything. And under digital signal also, draw the diagram. That is the first point. Under analog signal also draw the diagram, and under digital signal also draw the diagram and keep.
Sir, in both the signals, we have to draw the same diagram.
I'm just showing you this is analog and this is digital. How is it same diagram?
So we have to just draw this diagram in analog signal.
You have to draw, this is analog signal diagram and this is your digital signal diagram. Under analog this diagram, under digital this diagram.
Okay.
Under analog signal, draw the diagram. Under digital signal, draw the diagram for digital signal. This is the diagram for analog. This is the signal for digital. Okay. Now, second point under analog signal, see here, write down, see here, look at the screen. Second point, it is called continuous signal because it has continuous values. Right. It is called continuous signal because it has continuous values. It is called continuous signal because it has continuous values under analog signal. And under digital signal, write down, it is called discrete signal because it has only two values, 0 and maximum. So let me repeat. Under analog signal, the first point is the diagram. And the second point under analog signal is it is called as continuous signal because it has continuous values. Under digital signal, the diagram is the first point. And the second point is it is called discrete signal because it has only two values, either 0 or maximum. Okay. This completes the topic of types of signals. So go through. So there are two types, analog and digital. So 2 points under each. One diagram and 1 point. Here also one diagram and 1 point. Clear? Can I go to the next topic? This topic is clear. Small topic. There's a types of signals. Okay. Next topic is block diagram of communication system. Please make a note. Write the side heading. Block diagram of communication system. Right now. block diagram of communication system. Block diagram of communication system. Block diagram of communication system. So look at the screen. Look at the screen. See here. Everyone, look at the screen. This block diagram, I'll give you time to draw, but there is a logic to remember the block diagram. Now, everyone listen to me because now communication system topic will start. So see here. Imagine there is one person with the phone and that person is calling one more person on that person's phone. So this is person one with the phone. This is person two with the phone. Okay, just imagine. Now, this person wants to call this person and tell this person something. For example, if this person wants to call this person and tell, say hi, suppose. So see here, this person is called information source. And this person is called user of information. This person has some information. That is why this person is called information source. And this person is called user of information. Now the first person's phone is called transmitter because he's making a call to this phone. And the second person's phone is called the receiver. And how the phones connect is called the channel. Means right now our phones are connected through Zoom. Correct? Right now our phones are connected through Zoom. Therefore, our channel right now is Zoom. Correct? So for example, if this is me, if this is you, this is my mobile, this is your mobile, and Zoom is our channel, suppose. So can I say I am information source? You are the user of information. My mobile is the transmitter. Your mobile is the receiver. And our mobiles are connected through a channel. This is how you can remember the block diagram. Otherwise, the block diagram does not make any sense. Now, if you look at the block diagram, everyone look at the screen. Information source, transmitter, channel, receiver, and user of information. This is a block diagram of communication system. But while my phone is getting connected to your phone, there might be some disturbance in that link. That disturbance is called noise. If you look at the diagram, noise enters the channel. Means there is no problem with my phone, there is no problem with your phone. But sometimes while a connection is being established, sometimes when a connection has been established, you get some disturbance. That is called as noise. Okay, sometimes on rainy days or sometimes when you're in the lift, when you're in the train, the connection is not proper. That disturbance is called as noise. So if they ask you, explain block diagram of communication system, please look at the screen. If they ask you, explain the block diagram of communication system, it will come for 3 marks. 1 mark is for the diagram. Now I hope you can draw the diagram. It is easy. So can I say, this is nothing but information source, transmitter, channel, receiver, and user of information. And in the channel, who comes? Noise comes in the channel. That is the disturbance that comes in the channel. Therefore, you have written the side heading block diagram of communication system. Below that, draw this diagram, and then I'll give you the definition of each component one by one. Write down. Draw the diagram first. Once you're done drawing the diagram, put a dot so that we can continue with the notes. Okay, now listen. Below the diagram, write down the side heading. First one, transmitter. So write down the side heading, transmitter. So the first thing that you need to write is your transmitter. Now look at the diagram. Answer is in the question itself. Tell me, what does a transmitter do? Can I say transmitter converts message signal into transmitted signal? Easy. What does the transmitter do? Look at the diagram. Transmitter converts message signal into transmitted signal. Therefore, the side heading transmitter, below that write down, transmitter is a device which converts 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 message signal transmitter is a device which converts message signal into transmitted signal. Transmitter is a device which converts message signal into transmitted signal. Next side heading, write down receiver. Next side heading, write down receiver. Now look at the block diagram and can you define what is the definition of receiver? Look at the block diagram and tell me. Can I say receiver is a device which converts received signal back into message signal? Check the diagram. Can I say receiver is a device which converts received signal back into message signal? Therefore, write down side heading receiver. Below that, write down receiver is a device. Receiver is a device receiver is a device which converts receiver is a device which converts received signal. Receiver is a device which converts received signal back into the message signal. Receiver is a device which converts the received signal back into the message signal. Next side heading, write down channel. Next side heading, write down channel. Look at the screen. Now, can I say channel is nothing but a device which connects the transmitter to a receiver, or it is a link between transmitter to the receiver. For example, Zoom. Zoom is something that connects me to you, correct? So the link between transmitter to receiver is called as the channel, or the bridge between transmitter and receiver is called the channel. Therefore, write down side heading channel, and below that write down the link between the transmitter, the link between the transmitter and the receiver, the link between the transmitter and the receiver, the link between the transmitter and the receiver is called, the link between the transmitter and the receiver is called channel. And the next definition is called noise. And this is a very important definition. Okay. So look at the screen. Or before that, let me give you the definition, then I'll explain what does it mean. So first write down the definition of noise, then I'll explain what does it mean. Write down noise is random. Noise is random, unwanted. Noise is random, comma, unwanted electrical signal. Noise is random, comma, unwanted electrical signal that enters the communication system. Noise is random, comma, unwanted electrical signal that enters the communication system, that enters the communication system through the channel, that enters the communication system through the channel and interferes with and interferes with the transmitted signal and interferes with the transmitted signal and interferes with the transmitted signal.
So can you repeat the whole?
Noise is random, comma, unwanted electrical signal that enters the communication system through the channel and interferes with the transmitted signal. Finished? So see here, I'll give you the explanation, very easy. You should remember one thing about noise, that it is random and it is unwanted. Okay, what is it? It is random and it is unwanted. That means disturbance can come anywhere, anytime. It is random. Random means it can come anytime. Unwanted means it is not desirable. Okay, unwanted means it is not desirable. Therefore, the first thing you should know about noise is random and unwanted. The first thing that you should know about noise is random and unwanted electrical signal. Now look at the screen. How does it enter the communication system? It enters the communication system through the channel. And when it is entering the channel, it interferes with the transmitted signal. Check. Because transmitted signal is going through the channel, noise will come and interfere. Therefore, if you look at the definition, noise is, you can remember the code word run, that is random, unwanted, electrical signal that enters the communication system through the channel and interferes with the transmitted signal. That means the transmitted signal is going this way and the noise is going this way. So it interferes with the transmitted signal. Now this is the definition of noise. Is it clear? Therefore, when this question comes, you have to explain 1, 2, 3, 4. This completes your question for 3 marks. So if they ask you, what is the block diagram of communication system or explain communication system in brief, the first thing you should do is you should draw the diagram. Then you should explain what is transmitter, channel, receiver, and noise. You don't need to explain what is information source and you don't need to explain what is user of information because those are outside the system. So you need to explain these 4 definitions. Now see the diagram, see the 4 definitions, transmitter, receiver, channel, and noise, and tell me if you have understood this topic. So when this question comes for 3 marks, diagram is 1 mark, each definition is half mark. So read it. If you want me to repeat or explain anything, let me know. After this, we'll go to the next topic. Read the diagram, read the definition. Once you've understood, put a dot so that we can go to the next topic. Quick, just put a dot once you're done. Okay. Now, we have to complete this definitions. With that, the chapter is only over. Okay. So we have anyway done what is transmitter, receiver, channel, noise. This is a part of that previous question itself, correct? Definition of transmitter, definition of receiver, definition of channel, definition of noise. Now, we will do some important definitions. Therefore, in your notebook, write down side heading, some important definitions. Write down side heading, some important definitions. In your notebook, write down the side heading, some important definitions. Write down the side heading, some important definitions. Written side heading. And the first important definition is a transducer. The first important definition is a transducer. Write down side heading transducer. So write down the definition. A transducer is a device. A transducer is a device. A transducer is a device which converts. A transducer is a device which converts one form of energy into another form. A transducer is a device which converts one form of energy into other form. A transducer is a device which converts one form of energy into other form. Okay, stop writing. This is the definition. Now, for example, fan is a transducer. What is fan? Converts electrical energy into mechanical energy. Can I say even light is a transducer, tube light? Because it converts electrical energy into light energy. Therefore, any device which converts one form of energy into another form of energy is called as transducer. Okay? Any device that converts one form of energy into another form is called as transducer. Therefore, read the definition that you have written. Transducer is a device which converts one form of energy into another form. Correct? Next definition you write down is attenuation. Next heading you write down attenuation. Now, before you write the definition, listen to me. Before you write the definition, listen to me. You know, when any signal travels with distance, it loses its strength. For example, you take anything with distance, it loses its strength. For example, your Wi-Fi signal. You have a Wi-Fi router. Can I say with distance, the Wi-Fi router will lose its strength? Or if you take fire, can I say fire? If you light one fire, can I say with distance, the heat will go on decreasing? Or even if a person starts walking, can I say along with distance, the person will lose the strength as the person keeps walking? So any signal with distance, it loses its strength. Okay, imagine even if you fire a bullet from a gun, after a certain distance, the bullet also will fall down. Okay, therefore, any signal along with distance, it will lose its strength. This concept is called attenuation. Okay, so the loss of strength, don't write, listen. Any signal which travels certain distance will lose certain amount of strength. That concept is called as attenuation. Therefore, if you have written the side heading attenuation, write down the definition. The loss of strength of a signal, the loss of strength of a signal, the loss of strength of a signal while it travels through a medium, the loss of strength of a signal while it travels through a medium, the loss of strength of a signal while it travels through a medium, the loss of strength of a signal while it travels through a medium is called attenuation. The loss of strength of a signal while it travels through a medium is called attenuation. The loss of strength of a signal while it travels through a medium is called attenuation. The medium is vacuum. Veer. Medium is vacuum. Even vacuum is a medium. We call it one dielectric constant or constant one, but it is also medium. So I want you to read these two definitions. What is a transducer and what is attenuation? Transducer is a device which converts one form of energy into another form of energy. And attenuation is what? It is loss of strength of a signal while it travels through a medium. Is it clear? Now, the next definition that I'm going to give you is amplification. So write on the side heading, amplification. The next side heading, write down amplification. The next side heading, write down amplification. The next side heading, write down amplification. Now listen to me first, then I'll give you the definition. Listen to me. Amplification is the exact opposite of attenuation. If attenuation is the loss of strength of a signal, amplification is the increase in strength of a signal. Okay, everyone has heard the word amplifier or amplification. Amplification means increasing the strength of a signal is called amplification. Exactly opposite of attenuation. Attenuation is what? Loss of strength of a signal. Amplification is increase in the strength of a signal. Okay. Therefore, if you have written the side heading amplification, below that write down the process of increasing the strength of a signal, the process of increasing the strength of a signal, the process of increasing the strength of a signal, the process of increasing the strength of a signal is called amplification. The process of increasing the strength of a signal is called amplification. Full stop. Next point, under the same topic, amplification is carried out by a device. Amplification is carried out by a device called amplifier. Amplification is carried out by a device called amplifier. F-I-E-R. A-M-P-L-I-F-I-E-R. Is it clear? So read these three definitions. What is a transducer? What is attenuation? And what is amplification? Read three definitions: transducer, attenuation, and amplification. So we have done the definition of transducer, attenuation, amplification. Next definition, write down. Next definition, write down bandwidth. Next definition, you write down bandwidth. Next definition, you write down bandwidth. Bandwidth is the very, very simple definition. Look at the screen. There is actually a direct formula. So look at the formula. Bandwidth is nothing but F2 minus F1. This is the formula. Don't write anything right now. Listen to me. Where F2 is the higher frequency and F1 is the lower frequency. This is the concept. So higher frequency minus lower frequency, that width is called as bandwidth. Okay. Higher frequency minus lower frequency is called as bandwidth. Therefore, how do you write it in words? If I ask you define bandwidth, so what will you write down in words? Difference between highest frequency and lowest frequency is called as bandwidth. Okay. And this is the formula. And can anyone tell me what will be the unit of bandwidth? What will be the unit of bandwidth? It is higher frequency minus lower frequency. Hertz. Can I say it is frequency itself? Therefore, can I say the SI unit of bandwidth will be hertz? Okay. Therefore, write down side heading bandwidth. Below that, write down the difference between higher frequency and lower frequency. The difference between higher frequency and lower frequency the difference between higher frequency and lower frequency is called as bandwidth. The difference between higher frequency and lower frequency is called bandwidth. The difference between higher frequency and lower frequency is called bandwidth. Below that, write down this formula that bandwidth is equal to F2 minus F1, where F2 is higher frequency, F1 is lower frequency. Make a note. Bandwidth is nothing but F2 minus F1, where F2 is higher frequency and F1 is lower frequency. And below that, write down the SI unit of bandwidth is hertz. Below that, write down the SI unit of bandwidth is hertz. The SI unit of bandwidth is hertz. Okay, so now you got the definition of transducer, attenuation, amplification, bandwidth. Correct? Now, there are two more definitions, that is modulation and demodulation. In that, one more definition, range. Take it as your homework for today. Your homework is write down the definition of range. Range, you know, in your mobile also you have range, correct? Now you have to tell me what is the definition of range. This is your homework. What is the definition of range? Your homework is to tell me what is the definition of range. Is it fine? Now coming to a very important concept. Please understand this because many questions can be answered with this logic, okay, or with this topic. The topic is modulation and demodulation. Okay, this is the last topic of the chapter, one of the last topics. So please concentrate and listen. First thing you should know, modulation and demodulation are opposite. Means demodulation is the exact opposite of modulation. Therefore, if you come to know what is modulation, you will definitely come to know what is demodulation, because demodulation is the opposite of modulation. Now, I'll tell you in simple words. Putting something into something and sending it is called modulation. For example, you put your answer on the answer paper and send it for correction. That is called modulation. Putting something in something and sending it is called modulation. For example, putting your message on WhatsApp and sending it is called modulation. Did you understand? Putting something into something and sending it. Okay. For example, putting your food into plate and sending it into the dining table. That is called modulation. Or putting your answer on the answer paper and sending it for correction is called modulation. Demodulation is taking that thing out is called demodulation. So putting something is called modulation. Removing it is called demodulation. For example, when you put your answer on the answer paper, that is called modulation. And if the lecturer corrects the paper, means takes out the information, that is called demodulation. You sending a WhatsApp message to someone is called modulation. They reading that message is called demodulation. Did you understand the basic? Okay. So modulation is you put something into a larger thing and send it. Demodulation is they extract the information out of it. Okay. Same thing happens with courier. Courier means you put one courier thing into the parcel. That is called modulation. Demodulation is they open the parcel and take out the thing that you have given. So remember one thing, modulation always happens at the sender's end and demodulation always happens at the receiver's end, correct? Modulation always happens at the sender's end and demodulation always happens at the receiver's end. Okay. So I told you in very simple words what is modulation. Putting something into something is called modulation. Extracting the information out of that thing, that is called as demodulation. Therefore, you putting your answer in the answer paper is called modulation. The lecturer extracting your answer from the answer paper is called demodulation. You putting some message into WhatsApp is called modulation. The person reading the message from WhatsApp is called demodulation. Okay. Now, instead of saying putting something on something, the better word for putting is superposition. Superposition means adding it. Okay. So the definition is very simple. So I'll give you the definition, then I'll explain for modulation. But in general, did you understand this? Putting something on something and sending it is called modulation. And this happens at the sender end. And at the receiver end, demodulation happens. Okay. Therefore, write down the side heading, modulation. Write down. Superimposing. I'll give you the definition, then I'll explain. Okay. Write down. Superimposing a low frequency message signal. Superimposing a low frequency message signal on a high frequency carrier wave. Superimposing a low frequency message signal on a high frequency carrier wave for long distance transmission. For long distance transmission. For long distance transmission. is called modulation. Is called modulation. I'll repeat. Superimposing a low frequency message signal on a high frequency carrier wave for long distance transmission is called modulation. Okay. I will explain what is modulation and demodulation. First, let me give you the definitions, then I'll explain. Write on the side heading, demodulation. Write on the side heading, demodulation. Write down, retrieving the message signal. Retrieving the message signal from the carrier wave. Retrieving the message signal from the carrier wave. Retrieving the message signal from the carrier wave at the receiver's end. At the receiver's end is called, at the receiver's end is called demodulation. At the receiver's end is called demodulation. Full stop. Next sentence. Demodulation is the opposite of modulation. Demodulation is the opposite of modulation. Demodulation is the opposite of modulation.
Sir, please repeat. Sir, can you repeat the definition once?
Which definition? Modulation or demodulation?
Demodulation.
Demodulation. Retrieving of message signal from the carrier wave at the receiver's end is called demodulation. And demodulation is the opposite of modulation. Okay. Now let me explain what I have given you. Now consider WhatsApp itself. You have a message and you have WhatsApp. Now look at the screen. You putting your message on WhatsApp and WhatsApp will send your message. That is called modulation. Okay. And WhatsApp will act like your carrier. Check the definition. You know what is the meaning of carrier? Carrier is anything that carries. Okay, long distance. So see here. You put your message on WhatsApp is called as modulation. So your message will always have low frequency and WhatsApp will always have high frequency. So you putting your message on WhatsApp means you are superimposing your message on WhatsApp. Your message is a low frequency message and WhatsApp acts like a carrier. Therefore, see the definition. Superimposing. Superimposing means adding low frequency message signal on a high frequency carrier wave. Correct? Carrier wave means anything that carries your message. Now, what is the use of WhatsApp? The use of WhatsApp is something that carries your message for long distance. That is called as modulation. So listen to this. Superimposing. Superimposing means adding low frequency message signal on a high frequency carrier wave is called as modulation. Now look at the definition of demodulation. Someone receives your message and reads it, that is retrieving the message. And can I say, if you have sent it through WhatsApp, they can receive it through WhatsApp only. When you send a message someone through WhatsApp, so they retrieve the message from the carrier is called as demodulation. So look at me. You put something into WhatsApp and send it, that is called modulation. They will receive it and then they take the message out or they understand the message, that is called as demodulation. So your message is always low frequency and the carrier is high frequency. Carrier means something that carries your message. In this case, it is WhatsApp. You can use the same logic with courier. Look at this. Suppose you want to courier one pencil. Okay, suppose. Now your pencil will be your low frequency message. So the courier company will put it in a box. Correct? The courier company will put it in a box. That box will be your carrier. So can I say your pencil is inside a box? What is pencil? Your message. What is box? The carrier. And they will send it to whomever you want. That process is called modulation. The person receives the courier and takes the pencil out of the box. That is called demodulation. So putting the pencil in the box is called modulation at the sender end, and the person who receives it will take the pencil out is called as demodulation. So I'll give you one more example. Your answer is your message and your answer paper is your carrier, correct? What is the purpose of your answer paper? Answer paper is nothing but something that carries your answer from you to the professor, correct? Answer paper is nothing but a device or a paper which carries your answer from you to your faculty. So you putting your answer on the answer paper is called modulation. And the faculty reading your answer from the answer paper is called as demodulation. Okay, so look at the definition very carefully. Superimposing. Superimposing means adding low frequency message signal on a high frequency carrier wave. That is called as modulation. And what is demodulation? Retrieving the information from the message or from the carrier at the receiver's end is called demodulation. And demodulation is the exact opposite of modulation. Did you understand these two definitions? So based on these two definitions, there are a lot of questions in book back, which we will do. So read these two definitions and let me know if you have understood. Read the definition of modulation and read the definition of demodulation and let me know quick. Done reading what is the definition of modulation and what is the definition of demodulation. Okay. Now, this is your book bag questions. Just check in your book bag. These are the questions. Now, can anyone define what is a carrier wave? We have done the definition of modulation. We have done the definition of demodulation. Now, looking at these two definitions, can you tell me what will be the definition of carrier wave? Listen to me. Tell me if you have understood. Carrier wave is a high frequency wave on which low frequency message signal is superimposed for modulation. Did you understand? I just changed the answer of modulation into carrier wave. Listen to me again. Carrier wave is a high frequency wave that you already know from the definition of modulation. Carrier wave is a high frequency wave on which low frequency message is superimposed for long distance transmission. Can I say that I have just told you the definition of modulation in some other way? Okay. So now write down the question. What is a carrier wave? Write down so that I can give you the answer. It is just a different way of writing your answer. What is a carrier wave? What is a carrier wave? That is the question. What is a carrier wave? And write down the answer. Carrier wave is a high frequency. Carrier wave is a high frequency wave. Carrier wave is a high frequency wave on which low frequency message signal. Carrier wave is a high frequency wave on which low frequency message signal. Carrier wave is a high frequency wave on which low frequency message signal is superimposed for long distance transmission. For long distance transmission.
Sir, can you repeat the answer?
Carrier wave is a high frequency wave on which low frequency message signal or low frequency message is superimposed for long distance transmission. For long distance transmission. Is it fine? Okay. See the next question. I hope this question you have got it. Now see the next question. Why is high frequency carrier wave used for transmission of audio signal? Can anyone answer this? Why they are saying carrier wave has to be high frequency? Answer you anyway no. Again, answer is in modulation itself. Can anyone tell me the answer? Why high frequency carrier wave are used? Answer is for long distance transmission. Because if I want long distance transmission, frequency has to be high. Therefore, answer is direct. Again, can I say that the answer you already knew? Because that answer is there in modulation also. Therefore, write down this question. Why high frequency carrier wave are used for transmission? And the answer is for long distance transmission. So first write down the question and then write down the answer. For long distance transmission. So write down the whole question. Why high frequency carrier waves are used for transmission of audio signals? And below that write down for long distance transmission. Finished? Okay. Now see the next question in your book back. What is modulation? Can I say this we have already written as a part of our definition itself. What is modulation? Therefore, look at question number 13, 14, 15. Tell me whether you are in a position to answer all three. What is a carrier wave? Why high frequency carrier waves are used? And what is modulation? Just check 1, 2, 3. And let me know whether you are in a position to answer all three. Okay, now see the next question. What is meant by amplitude modulation that is omitted? You don't have this topic for your exam, so cancel it. You don't have this particular question in the exam. That is what is meant by amplitude modulation. This topic is omitted. Okay. See the next question. What is meant by noise? Can I say we have already finished this topic? What is meant by noise? We have taken the definition and we have written it also. What is meant by noise? See the next definition. What is meant by bandwidth? Can I say we have done this also? F2 minus F1. That is our definition of bandwidth. Now, what is demodulation? Can I say this definition also we have done? What is demodulation? Next one, what kind of modulation is required for television broadcast? It is not there, so cancel it. Okay, that is why read all the questions from 13 to 20 and let me know whether you have understood all. The ones which are omitted, leave it. Ones which are there, let me know if you can manage. Which are there, let me know you can manage. The ones which are there. Okay. Now, how is the effective power radiated? 21 is not there. Why should broadcasting programs use different frequencies? Not there. Now, explain the necessity of a carrier wave or carrier wave in a communication. Can you answer this? Explain the necessity of a carrier wave in communication. Can anyone answer this?
Sir, point-to-point communication and broadcast.
The question is not what are the types of communication. See the question, explain the necessity of a carrier wave. They are asking you, why do we need a carrier wave? Now listen to me. Why do you need WhatsApp? Why can't you tell the message to the other person directly? That is the question.
For
Not a note.
transmitting message to long distance.
Correct. Answer will be the same for long distance transmission. I need a carrier wave for long distance transmission. For example, why do you courier something to someone? Why can't you only go and give it? Because the distance is very far. Correct. Why can't you send a message to someone directly? Why do you need to send WhatsApp? Why can't you go to that person's house and tell? Because the distance is very far. So why do we need a carrier? We need a carrier so that they can carry it for long distance. Correct. Therefore, answer for this also is same for long distance transmission. Why do we need a carrier wave? We need a carrier wave for long distance transmission. Therefore, write down the question. Explain the necessity of a carrier wave in communication. Answer is for long distance transmission. Therefore, write down the question and write down the answer quick. Finished writing? Now, why does amplitude modulation give noisy reception? You don't have that. Amplitude modulation is omitted. Last one, explain why modulation is needed. This is there. Explain why modulation is needed. Now, can anyone answer why modulation is needed? Answer is nothing for long distance transmission, but in other words, you can write down the definition itself of modulation. So listen to me. Modulation is needed so that low frequency message signal can get superimposed on a carrier wave for long distance transmission. Can I say I've written the definition only of modulation? Therefore, write down the question. Explain why modulation is needed. Write down. Explain why modulation is needed. Write down the question. Then I will dictate the answer. Explain why modulation is needed. And write down the answer. Modulation is needed. Modulation is needed so that low frequency message signal. Modulation is needed so that low frequency message signal can be superimposed. Modulation is needed so that low frequency message signal can be superimposed on a high frequency carrier wave. Modulation is needed so that low frequency message signal can be superimposed on high frequency carrier wave for long distance transmission. For long distance transmission. That is why modulation is needed. Don't write that. That is full stop for long distance transmission. So now look at the whole page. Okay, all the questions, and tell me whether you are in a position to answer. Can I say all the questions are nothing but definition of modulation and demodulation only indirectly? So your answer, if you are getting confused in any answer, directly write the definition of modulation and demodulation if you are confused. Okay. Therefore, read this page. Tell me if you have any doubt on this page. Okay. If not, then I'll show you 2 or 3 more MCQs. With that, the topic will be over. So just read it and tell me if you are clear with the topic. Okay. Look at this, everyone. Tell me, have you finished the first one? This is your book bag only. I'm showing you the textbook itself. Tell me, have you finished the first one?
Yes, sir.
Have you finished the second one?
Yes, sir.
Now, start with third one and tell me what should be the answer for third MCQ. This is actually a ray optics question. You had it in your 10th also. Try to answer this and tell me what should be the answer for this particular question. How does frequency of a beam of ultraviolet light change when it travels from air to glass? Please remember, frequency does not change when it travels from air to glass. So frequency does not change, only wavelength changes. Frequency is a parameter which remains constant. It is a very important question in ray optics and wave optics also. So they'll ask you which parameter does not change when one light goes from medium to another. Answer is A, no change. So I want you to write the MCQ and please write the answer as no change because frequency does not depend on the medium. Therefore, write down what happens to the frequency when light travels, or any light, any electromagnetic wave from one medium to another. Answer is no change. Make a note. Okay. Explain how does frequency change? Answer is no change. Now, can you tell me the answer for the next one? What is the direction of electromagnetic wave? I told you all three are mutually perpendicular. Therefore, can I say electric and magnetic field are mutually perpendicular? Therefore, what will be the direction of EM wave? If one is x-axis, other one is y-axis, the answer should be z-axis. And if you have done mathematical methods, you know that I cross j will be k, or j cross k will be I. Remember cross product. All three are mutually perpendicular. Therefore, the direction of EM wave is always given as E vector cross B vector. That is electric field cross magnetic field, because we will get sign product. That is perpendicular. Therefore, please make a note of this MCQ as well. The direction of EM wave is given by E vector cross B vector. The direction of EM wave is given by E vector cross B vector. This is a cross product. If you have done mathematical methods, you will know. E is electric field and B is magnetic field. E is electric field and B is magnetic field. The direction of EM wave is given as E vector cross B vector. And the fifth one, we have anyway done it yesterday. Just check. MCQ 5, we have done it yesterday. The height of the TV tower is directly proportional to the distance is directly proportional to h power half. We have done this MCQ yesterday itself. Therefore, I want all of you to again read MCQ 1, 2, 3, 4, 5 and try to get the answer. Means you should be able to answer immediately for all 5 and let me know once all 5 are done. Read question 1, get the answer, so on, and put a dot once you have finished it. If you have any doubt, you can ask me in this file. Question number 6, that is MCQ number 6, take it as homework. MCQ number 6, take it as homework. And the same homework you can take as this question only. That means question number 6 and question number 6 and question number 2. Why are microwaves used in radar are both related questions. So take this as your homework 2 and take this as your homework 3. What is homework 1? Homework 1 is to write the definition of range. This is your homework 2, which is MCQ 6, and this is your homework 3. What is why microwaves used in radar? If you look at this question, you can answer this on your own actually. Okay, take on homework 2 and homework 3. Now, can I say MCQ 7? We have done it yesterday, and the answer was 32,000 meters. Just check. MCQ 7 we have just done yesterday, and the answer was 32,000 meters. Let me know whether you have written it. Yes? Okay. Now, come to the next one. Answer briefly. Say this. State 2 characteristics of electromagnetic wave. We have actually done 8 characteristics. Check your notebook and tell me whether this topic is done. State 2 characteristics of electromagnetic wave. I have done 8 characteristics of electromagnetic wave.
Yes, sir.
Done? Okay. Why are microwaves used in radar? That is your homework. That is your homework 3. Look at question number 3. What are electromagnetic waves? That is the definition of electromagnetic wave. Tell me whether we have done the definition of electromagnetic wave.
Yes, sir. Yes, sir.
Okay. So this is done. This is done. This is done. How are EM waves produced? I will come to this question. Question number 4, I will come to this question. Question number 5, I will come to this question. Question number 6 and question number 7, let us solve it. Question number 6, does ordinary light lamp emit electromagnetic wave? Can you give me the answer? Yes or no? Does an ordinary electric lamp emit electromagnetic wave? Think about it. This is the question. Does an ordinary electric lamp emit electromagnetic wave? So you have to try to answer this. Does an ordinary electric lamp emit electromagnetic waves? Answer is, tell me, ordinary electric lamp emits visible light, correct? Because we can see that light. And does visible light come under electromagnetic spectrum, or is visible light part of EM waves? Answer is yes, because visible light comes exactly in between. You have gamma rays, X-rays, UV rays, visible light. Therefore, can I say ordinary electric lamp emits visible light, and visible light is a part of electromagnetic spectrum? Therefore, can I say ordinary electric lamp will emit electromagnetic waves because it is light? Did you understand the question? Therefore, write down the question. I'll dictate the answer. Write down the question. Does an ordinary electric lamp emit EM waves? Write down the question. Does an ordinary electric lamp emit EM waves? Write down the question. Does an ordinary electric lamp emit EM waves? And write down the answer. Visible light has magnetic field also. Prem. Does an ordinary electric lamp emit EM waves? Answer is electric lamp emits visible light. Visible light emits. So electric lamp emits visible light. Electric lamp emits visible light, which is a part of electric lamp emits visible light, which is a part of EM spectrum. That means electromagnetic spectrum. Electric lamp emits visible light, which is a part of electromagnetic spectrum. And therefore, electric lamp will emit EM waves. Right? Electric lamp will emit EM waves.
Sir, repeat once.
Electric lamp emits visible light, which is a part of electromagnetic spectrum. Therefore, ordinary electric lamp will emit EM waves. Answer in simple words is yes. Okay. Now, see the next question. Why light waves travel in vacuum whereas sound waves cannot? Can anyone give me the answer for that? We have done this topic also.
Sound is longitudinal.
Can I say because light wave is transverse and sound wave is longitudinal? But you have to give the answer in such a way. Why light waves can travel in vacuum and sound waves cannot? You can say light wave is a transverse wave and transverse wave can travel in vacuum. Whereas sound wave is a longitudinal wave and longitudinal waves cannot travel in vacuum. Okay, this is how you have to write the answer. I will dictate anyway, so write down the question. Why light waves travel in vacuum whereas sound waves cannot? Write down. Why light waves travel in vacuum whereas sound wave cannot? Write down the question. Why light waves travel in vacuum whereas sound waves cannot? Okay, written. Now write the answer. Light wave is a transverse wave. Light wave is a transverse wave. Light wave is a transverse wave. And sound wave is a longitudinal wave. Light wave is a transverse wave and sound wave is a longitudinal wave. Light wave is a transverse wave and sound wave is a longitudinal wave. Full stop. Transverse waves can travel in vacuum. Transverse waves can travel in vacuum, whereas longitudinal waves cannot travel. Transverse waves can travel in vacuum, whereas longitudinal waves cannot travel. Therefore, light waves travel in vacuum, whereas sound waves cannot. Therefore, light waves travel in vacuum, whereas sound wave cannot. Therefore, light wave can travel in vacuum, whereas sound wave cannot. So this question is over. Okay, this question is over. This question is over. Now look at this question. Can we produce a pure electric or magnetic wave in space? Why? So answer is no, because every electric component will have a little bit of magnetic component and every magnetic component will have a little bit of electric component. That is why it is called electromagnetic wave. So can we produce a pure electric only? Answer is no. Can we produce a pure magnetic wave only? No, because every electric component will have a little bit of magnetic component and every magnetic component will have a little bit of electric component. Answer to this question is no, because in real life, both are together, electric and magnetic. Therefore, write on the question. I'll dictate the answer. Write on the question. Can we produce pure electric and magnetic wave in space? Why? Then I'll give you the answer. Write down. No. Answer. First write down no. Because the question is, can we produce pure electric or magnetic wave in space? Answer is no, comma, because every electric wave, no, comma, because every electric wave has partial magnetic component. Every electric wave has partial magnetic component and vice versa. Every electric wave has partial magnetic component and vice versa. Vice versa means magnetic wave will have a little bit of electric component. That's it. This is the answer. Okay. Now, tell me, first question clear? Straight to characteristics of electromagnetic wave. We have done it. This is your homework. What are electromagnetic waves? Is the definition of electromagnetic waves. That also you have taken in your notes. Can we produce this question we have done right now? Does ordinary electric lamp? This also we have done. Does light wave travel in vacuum and sound? That also we have done. Now, how are EM waves produced? This is the question. How are electromagnetic waves produced? For that, please listen to me. How are electromagnetic waves produced? Now, just remember one thing. When a charge, that is Q, is at rest, tell me which field does it have? When the charge is at rest, which field does it have? When a charge is at rest, so suppose there is a
Magnetic.
charge Q. So remember, when a charge is at rest, it has electric field only. When a charge is at rest, it has electric field only, very little bit of magnetic field, means negligible. In real life, I told you cannot have pure electric field, little bit of magnetic field will be there, we'll take it negligible. Can I say a charge at rest has electric field only, and when the charge starts to move, it will develop a magnetic field around it. Therefore, when a charge is moving, it has electric field as well as magnetic field. Remember this in every chapter in your 12th standard also. A charge at rest has electric field only, but a charge which is moving has electric field as well as magnetic field. Therefore, to get electromagnetic wave, can I say a charge should move? A charge cannot be at rest. A charge should move. Therefore, how do I produce an electromagnetic wave? By accelerating a charge or by moving a charge. Or in simple words, if they have asked you, how are EM waves produced? Answer is by accelerated charges. Simple answer, just 2 words, by accelerated charges. Why not normal charge? Normal charge can be stationary also. Stationary charge has electric field only. Normal charge has electric field only. But a moving charge has electric field as well as magnetic field. A moving charge has electric field as well as magnetic field. Therefore, please remember this throughout. Stationary charge has electric field only, and an accelerated charge has electric field as well as magnetic field. Remember this concept. So if you want, you can write down as a note in your notebook. Write down, a stationary charge has electric field only. A stationary charge has electric field only, whereas an accelerated charge, whereas an accelerated charge has electric as well as magnetic field. Whereas an accelerated charge has electric field as well as magnetic field. Is this much clear? So write down this question. How are EM waves produced? And the answer is just 2 words. The answer is accelerated charge. Answer is accelerated charge. If they ask you why not stationary charge, you can answer stationary charge produces electric field. An accelerated charge produces electric field as well as magnetic field. Okay, now I'm showing you the book back questions again. So all of you look at this page itself. That is page number 240. You should be in a position to answer this, and this right now. This is your homework 2. And in answer briefly, this is your homework 3. You should be able to answer all and should be able to answer very quickly. So look at this particular page, page number 240, and tell me whether you are in a position to answer all questions other than the homework ones. Just check. Any doubt, let me know in any of the questions. Then we go to the next page.
The second question, repeat करो ना. Answer in this.
Second question means which one?
So why microwaves using a radar?
That is your homework. Homework 3.
Okay.
And this is your homework 2.
Okay.
Now we have done, please give special importance to 4, 5, 6, 7. These questions, 4, 5, 6, 7, which we have done just now. Four, 5, 6, 7. Okay.
Yes, sir.
So yeah, this is your next page. First, let us come to the numerical problems. Then we'll go to the other ones. Can I say in my last class, we have finished these numericals? 1, 2, 3, 4, 5, 6. Just confirm whether we have done this. Where 1 to 5 was done using the formula C is equal to lambda into nu. And the sixth one was done using the formula E vector is equal to C into B vector. Just confirm whether we have done this. 1, 2, 3, 4, 5, 6.
Yes, sir.
Easy. Now, also look at question number 8 and 9. We have done this yesterday itself. Just check question number 8 and 9. We have done it yesterday, where I said that height of the tower should be double to get double the area. The same question we have done yesterday. And then I told you to do this question also yesterday, where there are two heights, 32 and 50. Just tell me whether we have covered these two questions yesterday.
Yes, sir.
Covered? Clear? So can I say first question, second question, all the questions of numericals are covered except this one. Okay. So we will solve this right now. Can I say after I solve this, all my questions are done? All my numericals of this chapter are done. Okay. Now I want all of you to look at this question. That is question number 7. And I want you to, we'll do it together. So everyone look at question number 7. It is a different question. So listen to me first. What I want all of you to do is, in question number 7, I want all of you to find out area covered by an antenna first. Now tell me, what is the formula for area covered by an antenna? Look at the screen. Can I say it is pi d square, what we have done yesterday? Or area is nothing but pi into, what is d square? D is nothing but square root of 2RH the whole square. Or can I say area is pi into 2RH? Correct? Is it fine? Now, a TV tower has a height of 200 meters. How much population is covered by the TV transmission if the average population density is so much? I will tell you how to do it. But first, find the area covered. Start. Find the area covered. Height is given as 200 meters. So tell me what is the area covered. Tell me what is the answer for area covered. Okay, so I will do it. Height is, have the correct. Height is 200 meter. Now all of you once look at the screen. I'll tell you one shortcut how to do it. Okay, see here, look at the screen. Can I say height is 200 meter and I have to find area first? Please look at the screen. Now, what is the formula for area? The formula for area is pi d square. Or can I say area is pi into, what is the formula for d? Square root of 2rh the whole square. Or what is the formula for area? Pi into 2 into r into h. Now, area is equal to pi into 2 into, what is r? 6.4 into 10 power 6. And what is height? 200. Now look at the shortcut and look at how I do it. You can use this shortcut in all problems. See here. Area is pi into 2. 6.4, I'll approximate it to 2 pi. It is not exactly 2 pi, but approximately 2 pi. Think about it. Can I say pi is 3.14? 3.14 into 2 is 6 point something, correct? So can I say approximately equal to 6.4? Not exactly, but approximately equal to, okay? Into 10 power 6 into 200. Understood the first approximation that I did? And I want you to do this in every problem of area. And I'll tell you why. Now, can I say, see here, pi into pi will be pi square. Therefore, can I say 2 into 2 will be 4, pi into pi will be pi square into 10 power 6 into 200. Tell me whether this step is clear. Now, look at one more approximation. Now, this approximation is very important. 4 as it is, pi square, I will assume it to be 10. Very, very important. Just think about it. Pi square is what? 3.14 square, which is 9 point something, which I'll assume it to be 10, which will work very well for you in such kind of problems. So the first approximation that you should do is in all problems of area. Please look at the screen. 6 point something, you should take it as 2 pi. This pi and this pi will become pi square, and always approximate pi square to be 10. Not only in this chapter, in any chapter of physics, when you get pi square, you can always round it off to 10. Okay, continue. 4 into pi square is 10 into 10 power 6 into 200. Now, can I say 4 into 200 is 800 into 10 power 6 and 10 is 10 power 7. Or can I say it is 8 into 10 power 9? Can I say this is the area covered? Tell me, did you understand till here? If you do it with the calculator, if you do it exactly as per pi square, you will get 8.038. Here you will get 8. Check. Did you understand the first step? How to find the area? That is 8 into 10 power 9. Clear? Now, look at the question. They have not asked the area. If you look at the question, they have not asked the area. What they have asked is, how much of population is covered in that area if the population density is 1000 per kilometer square. Now, whenever this kind of question comes, you have to divide the area by your population density. Means that much population is there in that area. Now, what is the population in this area? 1000. Therefore, whatever answer I got for area, if I divide by 1000, tell me what is 8 into 10 power 9 divided by 1000? Can anyone tell me the answer? 1000 is nothing but 10 power 3. What is 10 power 9
8 into
divided by
10 power 6.
6.
10 raised to 6. Can I say 10 power 9 divided by 10 power 3 is 10 power 6? Therefore, my final answer is 8 into 10 power 6. Now, if you look at the answer, this is the answer. Did you understand how to do this kind of question? So whenever population density is given, first find the area. Then whatever population density is given in whatever unit, whatever form, directly divide your area by that. And remember, answer will not have any unit. Just check, because how much of population is covered, that's what they are asking. Did you understand this kind of question? Okay, so in this kind of question, first you have to just find area. And I told you how to find the shortcut. Always take 6.4 as 2 pi. Always take 6.4 as 2 pi. And pi into pi will become pi square. And pi square you can take it as 10. And then you can continue. Now can you solve it and tell me whether you're getting the answer as 8 into 10 power 6. So start. Do it the same way. First get area, that is 8 into 10 power 9. Divide it, get this answer, and let me know in the message box that you have got it. Okay, this is a book back question, so it is important. So solve it and let me know. I'll give you one more minute. I've got answers from few people, others also confirm that you have got it. Okay, now, so look at the answers of solve the numerical and confirm whether you can solve all the numericals. We have done all the numericals. So please confirm, just look at all the numericals in your textbook, page number 241, and tell me whether you can manage all the numericals. Can manage? Okay, now look at this. Can I say what are ultraviolet waves give to users? Ultraviolet rays are a part of electromagnetic spectrum. Give to users, you had it as homework. Tell me whether you can manage this question.
Yes,
Two
sir.
uses of ultraviolet rays, actually 3 uses and 3 properties was your homework. Can you manage this question? Okay. What are radio waves? Give it 2 uses. Can you manage this question also? Because even this was your homework question. Okay. Name the most harmful radiation entering the Earth's atmosphere from outer space. This is your homework 4, but I have done it yesterday, so we can convert it into our classwork itself and tell me. This was a part of our atmosphere. Tell me, what is it?
UV.
UV rays, correct. And what protects us from the UV rays?
Ozone layer.
Stratosphere.
Here.
Yes, ozone layer, which is a part of the stratosphere. So I want you to write this question. Name the most harmful radiation entering the Earth's atmosphere from outer space. Listen, listen. Write this, and then I will dictate the answer. Write the question. This is question number 10. So what will you write the answer as? UV radiations. Write down. What is the most harmful radiation? Write down UV radiations. Full stop. And also write it, because in the exam they'll ask you who protects it, what happens. Write down. Ozone layer. Ozone layer, which is a part of the stratosphere. Ozone layer, which is a part of the stratosphere, protects the Earth from the harmful UV radiations. Protects the Earth from the harmful UV radiations of the sun. Finished? Now, next question, give reasons for the following. It is omitted, means you don't have that topic. So cancel that topic. That is question number 11, cancel it. From question number 12, name 3 basic units of any communication system. Can you answer this? What are the 3 basic units of any
Transmitter, channel, receiver.
transmitter, channel, receiver? Therefore, write down this question and write down. Don't write the definition, just write the names. So write down the question and write it as question number 12 itself, so that you know it's a book back question. Name the 3 basic units of any communication system and write down the answer. Transmitter, channel, and receiver. Transmitter, channel, and receiver.
Sir, can you repeat it again?
Yeah. Name the 3 basic units of any communication system. That is the question. Answer is transmitter, channel, receiver. Answer is transmitter, channel, receiver. Written? Now, can I say the questions after that we have anyway discussed as a part of my module? Just check all these questions were there as a part of one page where we have done all. So what is a carrier wave? We have done. Why high frequency carrier waves are used? We have done. What is modulation? We have done. What is amplitude modulation? Is not there. What is meant by noise? What is meant by bandwidth? Demodulation we have done. This is not there. This is not there. This we have done. This is not there. And this we have done. Check. With that, we have completed all questions of movement. Let me know. Look at this page and let me know if you have doubts on any question on this page. Okay. With that, we complete the chapter. We have done all book back questions. So let me know if you are clear. And if you have any doubt, please ask.
Sir, question number 22 is there.
Question number,
22.
why should broadcasting programs use different frequencies? That one?
Yes, sir.
No.
Okay.
Correct, Shubham. Whatever I have done, don't do that much. In fact, we have done all book back questions. Correct. In this chapter, I'll repeat again, give importance to MCQs and give importance to solve the numerical problems, because that is the only thing that usually comes. That is why in this chapter, first thing you should do is solve all the numerical problems. That is always there. Okay. And then do the MCQs. Other things you can refer my notes. It's an easy chapter, very less formula, mostly theory. Clear, all of you? Okay. So with that, we finish this chapter. So take a 15-minute break. After that, I will do a little bit of semiconductors, one topic, and then we will stop. For morning batch, we have completed semiconductors. So if you want, you can attend for revision. But for evening batch and for Thakur, we will have to do semiconductors. I will just do the 1 or 2 topics, which are very small, and then we will stop. So 9:35 login, and then we will do 2 topics, and then we will stop as soon as we complete 2 topics. Okay, I just want to give you introduction of semiconductors. So take a 15-minute break and log in for semiconductors. Thank you. Bye-bye.
Bye, sir.